Welcome to Intro to Calculus. So now that we're in Chapter 11, we have finished with all of our essential skills for this entire year, which is pretty exciting. Now we're actually going to talk about calculus, getting you ready for next year. So we're going to split this over a couple of different pieces. So 11.1 Intro to Limits. We're going to do a lot of limits in this first section, I think most of them just by graphing. So I will be pausing and restarting many times because I know you know how to graph most of this stuff. So the first thing that we're going to do on number 1 is just graph the equation for f of x is equal to 2x minus 1, which if you recall is just the equation of a line. Okay, so now we have the equation. So what I want to do is I want to look at that x value that I'm attempting to approach for the limit. So down here at the very bottom, that's what I'm going to focus on. Now remember, with limits, it's not about actually getting there. It's about the approach. So what I'm going to do is I'm going to go to where x equals 3. So x equals 3 down here. And I'm going to go up to where my graph is. And I'm just going to kind of put like a little flashing light there. So that's really what I care about. That's where I'm trying to get. Now if I get there, great. If I don't, that's okay too. It's about the approach. So we're going to come in from the left and the right hand side. So as we come zooming in from the left hand side, so from negative infinity, as we get closer and closer and closer to that point, we want to see what the behavior of the graph is and what y value it is that we're approaching. So as you see, notice that as I get closer and closer and closer to the graph and to the behavior of the graph, I start sliding up the graph on this one, and I'm approaching whatever that y value is. Well, it looks like from the left-hand side, I'm approaching a y value of 5. So I think I'm getting really close to this y value of 5 coming in from the left-hand side. So now I want to see if I'm going to approach the exact same value coming in from the right-hand side. If the right-hand side and the left-hand side approach is the same, you're approaching the same value, then your limit exists, and it's whatever that value is. So here we go. Let's go ahead and extend this. Let me see if this will let me do it. Let's go ahead and extend this line just a little bit up here. All right, so as I come in from the left-hand side, way over here, as I come in from the left, notice that I have to kind of start curling in the direction of the graph. And I want to see what y value it is that I'm approaching. Lo and behold, as I come in from the right, I'm also approaching a y value of 5. Since the limit from the left-hand side and the limit from the right-hand side, so as I'm approaching, I'm getting close to that exact same y value. Because these y values are the exact same thing, that means that my limit is going to be that value. The limit is going to be 5. So it is about the y value that I'm trying to get close to. Okay, let's take a look at this next one. This next one might require just a little bit of work, but it's the idea of just writing a table for this. So I am not going to write the table down. I am just going to kind of talk my way through it. So make sure that you're listening to me on this one. Make sure I don't lose you guys. All right, so let's start plugging in values that we know. So if I plug in 1, well, the absolute value of 1 is 1, divided by 1 is just 1. So I get the 0.11. If I plug in 2, absolute value of 2 is 2, divided by 2 is still just 1. And if I keep going in that fashion, if I plug in 3 or 4 or 5, I'm finding the absolute value of the number, which is just the positive of that number, and then dividing it by itself, which is still just going to give me 1. So what I'm going to have here is I'm going to have a line. Now, I'm not totally sure what's happening at 0 yet, so we're going to kind of ignore that for now. And then we're going to look at the behavior and see if we can decide what's going on. All right, let's plug in some negative numbers. If I plug in -1, absolute value of -1 is positive 1, but I'm still plugging in -1 as a value, so -1's in the bottom. So positive 1 divided by -1 is going to give me -1. All right, so now I'm down here. If I plug in -2, absolute value of that is positive, but if I divide it by negative, I still get -1. Notice I have the exact same pattern kind of happening along the side here. Even all of those decimals and fractions, I'm still going to get that either positive 1 or negative 1 value. All right, so here's why I didn't fill in the 0. We have to decide if this is going to be a whole or an asymptote. Well, the idea of an asymptote is that our graph typically races towards it and hugs it. Well, I don't see any racing or hugging happening here. What we actually have is a jump in the graph. So this graph is going to be continuous everywhere. So you can draw your pencil on this thing, except when it gets to 0. So what we're going to have is we're going to have a big old jump right here. Now keep in mind that we are still going to have all of those negative numbers and positive numbers leading up to 0. Just so happens that at 0 it's not going to be working. So I'm going to do the exact same thing. I'm going to go ahead and grab I think I used an orange pen before. I want to take a look at what it is that I'm trying to approach here, which is 0. All right, now I think what I'm going to do is I am going to kind of draw a line here so I know where it is that I'm trying to get to. And I'm drawing the line here because that line is at x equals 0. All right, so let's come in from the left and let's come in from the right and see what happens. So as I come in from the left-hand side, it doesn't matter where you come in from, but as you come in from the left, you want to try to get close to that graph that's there. Remember, it's not about getting there, it's about the approach. Well, it looks like I'm approaching that value. Notice I don't get there, but I'm getting super close, which is good. So I think that from the left-hand side, it looks like I'm getting close to negative 1. All right, from the right-hand side, I'm going to do the same thing. I'm going to go ahead and approach from the right-hand side, but I want to kind of get close to that graph because I want to see what it's doing. So as I approach from the right-hand side, notice that it's getting really close to this y value. That y value is at 1. Now if we take a look at these two, I've got my coming from the left-hand side is negative 1, coming from the right-hand side is positive 1. Those are not the same number at all. Because of that, we would say that this limit does not exist. In order for the limit to exist, one of the main things is to make sure that you're approaching the exact same value from both left and right. Let's take a look at the next slide. Okay, so we have some more graphs here. All right, so our first one, we have a piecewise defined function. Again, I'm just going to quickly graph this. Make sure, it seems to want to grab the bottom of that point, so we're just going to let it. I'm going to go ahead and plot what we've got here. So this first part says that f of x is equal to 2, so y is equal to 2. Y equals 2 is just a horizontal line when x does not equal 3. Okay, so I don't want to be at x equals 3. So at x equals 3, I'm going to watch out for this guy right here. Got to be careful. But I want y equals 2 everywhere else. All right. So there's the line y equals 2. But it doesn't exist right there when x is equal to 3. Well, when x is equal to 3, this is where the second part comes in, our y is going to be 0. So that puts us down here, actually. Okay, so it looks like we have this single point of discontinuity. So we still have a hole in the graph, but it actually looks like it's jumped somewhere else, which is fine. There's nothing wrong with that. All right, so let's take a look at what we're interested in. So I'm trying to approach 3. All right, so since I'm not totally sure what's going to be happening here, I'm going to draw a line again right at 3. Because that is going to be my focus. All right, and I'm going to come in from the left and come in from the right and see what happens. So coming in from the left, we're going to do the same thing. I'm going to try to hug that graph and get as close to it as I can, because if you get there, great. If you don't, that's okay too, but you still want to try to get close to it. All right, so it looks like as I'm coming in from the left-hand side, it looks like I'm actually approaching that y value. So it looks like that's at 2. All right, so from the left, looks like we're coming into 2. All right, let's do the right-hand side. So do the exact same thing. So I'm going to come in from the right-hand side. I'm going to try to get close to this graph. Well, it looks like I'm getting really close to that y value. Well, that y value is at 2. Notice that I do have that point of discontinuity, but it doesn't affect my limit at all, because remember, it's about the approach. So as I come in from the left, looks like I'm getting close to 2. As I come in from the right, looks like I'm getting close to 2. that means that the limit is 2. Remember, it's not about getting there. All right, so I'm going to go ahead and pause for a minute. Let's take a minute, graph this equation, and then we can take a look at the limits. Okay, so here we have our graph of 1 over x squared. What we want to do, I'm going to go ahead and focus in on what we're trying to get close to, which is 0. All right, so I'm going to do the same thing. I'm going to go ahead and highlight. Now I see that it looks like it's dashed because it's an asymptote, so I'm going to keep it dashed. But I want to go towards that point. All right, let's come in from the left-hand side. All right, as we come in from the left-hand side, and we try following this graph, because of that asymptote, this thing blows up. We don't have a y value that we're approaching, so the only idea I can come up with to represent a number, we know it's not a number, but it's infinity. Well, limit's only going to exist if it's actually approaching a value, an actual number, not the idea of a number, an actual number. All right, so I think we're in trouble on the left-hand side. Let's take a look at the right-hand side. We'll do the exact same thing. We're going to come in from the right. We're going to try to get close to whatever y value it looks like it's peaking out at. Well, this side's also going off to infinity. All right, so although the values on the left and the right-hand side are the same, they're infinity, though, and infinity is not an actual number. It's the idea that there is something else out there. So our limit here is not going to exist. So in a nutshell, we're going to talk about a couple of different things that you can do to be able to evaluate limits. But if you're not sure, you can always graph it and just see what it does. And remember, it's about the approach. If you get there, great. If you don't, that's okay too. It's just about getting as close as possible to it.